Hey there, in this video we're going to be talking about object-oriented programming. Really the ultimate goal of this video is to help you understand object-oriented programming from a real-life object to code approach. And this will make a little bit more sense as we go into the video. I should make note that the more advanced concepts like inheritance, polymorphism, abstraction, and encapsulation are left out for this video because I want to make sure that you understand the fundamentals. Hi, I'm Brandon from Learning Code Online, where I help you with your programming journey. I offer courses, tutorials, as well as Python tutoring to help kind of get your feet off the ground and get going with programming. If you're interested in what we do, head on over to learningcodeonline.com. We also send out a monthly newsletter covering various topics within programming, not only keeping up to date with what we do, but also covering topics like artificial intelligence and even some of the industry highlights and news. If you're interested in that, we've left a link in the description below for you to go and sign up. So what exactly is object-oriented programming? Before I dive into the code and give you some kind of formal definition, I want us to take a step back and look at everything that is currently surrounding you in the room that you're currently in. Everything that you're looking at is an object. All objects have some kind of characteristic associated with it, whether if it would be color or texture or material, shape, size, things that describe the object. So for instance, the picture on your wall, it's probably a rectangle, or maybe it's a circle. It could be made up of plastic, or it could be glass. These objects also have functionality associated with it. So for instance, your TV turns on and off. Your remote has that driver functionality to be able to turn the TV on and off, switch the channels, turn the volume up, turn the volume down. We can actually represent these real-life objects in a programmatic way through object-oriented programming. All objects inside of Python have some kind of characteristic that describes it, whether if it would be color, shape, size, just like I had mentioned earlier. And similarly, all of these objects in Python have some kind of functionality associated with it. So really, at the end of the day, object-oriented programming is really all about being able to reuse code at scale. So for instance, on a website, you can have multiple users, but every user is its own object. Every user has a first and a last name, as well as an email. And every user might be able to have some functionality to update their email or update their first and last name. One really cool thing about object-oriented programming is that objects are able to interact with other objects, similar to how your TV and remote react with one another, right? We push the on button on our remote and we see that our TV turns on. We push the volume button on our remote and we see that the volume, well, here I should say, we hear the volume go up on our TV. The exact same thing can happen inside of Python. An object can trigger functionality to change the behavior of another object. So hopefully that provides some kind of background, even if it didn't make full 100% clear sense. And there's my cat, Athena. What? Hi. So hopefully that provided a little bit of contextual information as to what we're talking about when it comes to objects. But let's actually go ahead and build an object so you see exactly what I mean. And we're going to use something that you use practically every single day, or you may not use every single day, but that's probably sitting near you or in front of you on your desk, a pen. So for the remainder of this video, what we're going to do, was that my cat that just zoomed by? So for the remainder of this video, we are going to be analyzing this pen and determining the functionality and the behavior, as well as some characteristics of it. We are then going to express from a programmatic standpoint what this would look like if we were to code it up. Okay, so let's go ahead and start analyzing our pen a little bit here. And on the side, I'm just going to go ahead and jot down a few methods and attributes that we may want to include as we're starting to build out this class. So just upon inspection here, we notice that the ink color for this is going to be black. So one of the attributes, or I've been saying characteristic, but really we're going to start referring it to as an attribute because that's kind of what it's called, is the fact that the ink color is black. In addition, there's also an ink level that we have to kind of keep track of because one of the requirements for us to be able to write with a pen is, well, the ink level. If you don't have any ink, you can't write anything. And just for the sake of it, we'll also mark down the material. So in this case, it's going to be plastic for this specific pen. I want to now talk about the functionality, which I'm going to now refer to as methods. As I had just said, there's some kind of retractability feature with this, right? We're able to write with it while it is not retracted, and then when it's retracted, we can't write with it. So we'll add that in as some kind of functionality, or method, I should say. In addition, we also have this functionality to where we're able to check our ink. So if I were to pop this thing open, right, pull out the ink cartridge, we see that I'm running really low on ink. So I want to have some functionality to be able to not only check the ink, but also replace the cartridge as a whole. But of course, the most important part about the pen is being able to write. So we're going to add in some kind of write method. So now that we've identified all the important things about our little pen right here, I think it's time for us to start diving into the code and actually building it out as if we were building a pen with code. But before we go ahead and dive into the code, take a second to like this video and also subscribe to the channel. We're going to be putting out a lot more content similar to this one, so if you like it up to this point, be sure to hit that like button and be sure to hit subscribe. Okay, so go ahead and boot up an editor of your choice. For me, it's going to be Visual Studio Code. I'm going to go ahead and create a new Python file. We're going to call that pen.py. And this is just going to pop open a new Python file. So the way that we create objects inside of Python is with the class keyword. For me, I'm going to call this pen. And you can call it whatever you'd like. This could be cat. This could be pencil. Whatever you want it to be, you're giving it a name. Now, in older versions of Python, you might see these empty parentheses here. In Python's version 3 and up, you don't need these anymore. But for Python version 2.7, you're going to want to have those there because, well, that's just how the language is. You may also see some other things inside of there. For our purposes, we're not going to worry about what goes inside of there because that goes hand in hand with what we had talked about earlier with one of the 4 more advanced concepts, inheritance. Not going to dive into that here, so we're just going to leave that off. One other thing that I want to make mention of right out of the gates is the fact that the white space, or the indentation, I should say. So the indentation is very important here because anything that's indented underneath this class reserved word is going to be part of that class. So inside of here, we're going to be stuffing our methods, which are just functions, and then also our attributes, which are just variables. So I'm going to go ahead and throw up the different methods that we had talked about, not too long ago. So the first thing that we're going to do with this is we're just going to stub it out, right? We're going to write the methods and have those in place, but we're not going to fill in those methods. So if we do def write, you'll also notice that I included this self keyword. We'll talk about what that is here shortly, but you're going to want to have that in every single one of your methods. The only exceptions to this is whenever you're doing static methods or you're doing class methods, but again, that's a little outside of the scope of this video, so we won't be including that. So then we'll also have def retract self. Awesome. So if we run this code as it is, let's see what happens. We see that nothing happens. Let me actually do this, make it a little easier for you. Hit run, nothing happens. Why? Well, because the class is just defined. It's not instantiated. Similar to how whenever writing our methods, test, print, hello, right? The reason why we're not printing hello is because we're not calling the method. If we were to do test, just like this, right, we see that it does print out because we're telling the Python interpreter, I want you to run this method. Similarly, with this class, right, we have to instantiate it. So we'll do my pen equals pen. And this is how we instantiate an object. And I'm going to leave this here for right now, but if we run it, nothing happens. It's not because we're saying that we don't want anything to happen, it's because we haven't told our class what to do, right? My pen. Okay, so back to this self argument. Why do we need it? What does it mean? It refers to that specific instance of a pen. We create an instance of a pen just like this. So I'm actually going to write create an instance of the pen. So if I wanted to create another instance of the pen, my other pen equals pen. This is how we would do it. So the cool thing here is that we have two pens that are completely decoupled from one another. So we can say my pen dot write, and that's going to write with this pen object, not this pen object. So if we need to refill the ink cartridge to this pen, we just call refill ink, and it will refill the ink cartridge for this one, not this one. So it allows for that decoupledness between two of the same objects. That's what that self is it's referring to that instance of the object. And if it's not apparent now, hopefully it'll be a little bit more apparent as we progress through this video. Okay, so let's go ahead and actually add in one more method that we did not talk about. And it's kind of a special method, and I'd highly recommend that you include this in every single one of your classes, just because this is that starter code, so to say. And this is called the init function, right? You may have heard of it as the constructor in some other languages like Java. In Python, it's just initialization. You could call it a constructor if you want to. You know, we're not going to get fancy dancy with the terminology. It's just like any other method that we created here. It can take in parameters and it can do some really cool logic straight out of the gates without having to call another method. And this is really advantageous in a lot of manners, and I'm not going to explain it right here, right now, because it's going to be one of those things that becomes more and more apparent as you work with it over time. So before we dive into actually building out this functionality, let's go ahead and define some of our attributes that we had talked about earlier. So we can do color equals black, material equals plastic, ink level equals 100. So the reason why I'm doing ink level equals 100 is because we have to have some way to track the ink level. We can have it as like a percentage. We can have it as a number, right? 100 means it's filled up all the way. 0 means it's empty. So we'll just go ahead and leave a comment here. 0 means empty. So I want to leverage this self real quick. These variables that I'm declaring here are only scoped to this function. As soon as that function, or method in this case, I should say, whenever that method is done running, it gets removed from memory, right? And you no longer have access to these variables. So we're actually going to put the word self in front of it. And what that's going to do is that's going to say, okay, now I want you to take this variable color and I want you to bind it to our pen class instead. So that way, as long as this object stays alive in memory, this attribute or variable is going to be staying alive alongside of it. Went ahead and did the same with all the other things. So if we go ahead and hit run, oh, there's still nothing there. So let's talk about how we can kind of access these different attributes. I'm going to go ahead and get rid of this. We're going to do print my pen. And the way we access our attributes is through this dot operator. You may have seen it in some other code, like if you ever use the matplotlib library, you'll use plt.plot, right? Kind of the same thing here. So mypen.color, we actually see inside of our tooltip here, the color, the check ink, right? This little icon in Visual Studio Code is going to be your attribute, and then this is going to be a method. So if we do print mypen.color, we see that it's black. But now, what if we wanted to have a red pen, not a black pen? Well, we can take this one step further and just kind of ask the user what they want. And the way that we're going to implement this is not through that input function, but rather less a parameter, right? We're going to have this to be a string. So if we do self.color equals color, right? Don't get confused here. This color is referring to what you're reading in as a parameter. This color is referring to the instance for pen. Same thing here. We're going to do material equals, actually we're going to do material str. I'm going to set that default to be plastic because most pens are plastic. Cool. So if we hit run, oh, we get a problem, right? Our init function is missing one required positional argument. That's color. So here we want to do black. Let's do another one. Red pen equals pen red. So if we do my pen, so we're going to rename this to black pen, and then we do print red pen dot color. Go ahead and hit run. We see black and we see red. Now I think it's time for us to implement these methods right here. First thing is first, I say let's go ahead and just write out, I don't know, this check ink level. I think that this is one of the easier ones to implement. So inside of our methods here, I'm going to add in a doc string. So this doc string is just like a summary of what this method does. So here we're going to be returns the value of the current ink level. And to do that, it's just going to be return self.ink level. Remember, at the end of the day, these are just methods, or I'm sorry, these are just functions. So now that we have this check ink, I think it's time for us to implement this refill ink. And the way that we're going to do this is by setting self.ink level to be 100. So in order for us to do this refill ink, what we're going to do is self.ink level equals 100. And what this does is it just takes that ink level and sets it back to 100, meaning that we now have a full cartridge and we could just continue writing. So this retract method is going to be a little bit different. What we need to do inside of our init method is actually add in a new variable to keep track of whether our pen is retracted or not. So say that you just pulled this off the shelf and you go to the cash register to buy it. Is the pen retracted or not? Well, it'd be pretty silly if you get it packaged and it looks like this, right? You want it to look like this so that way that ink doesn't dry out. So we're gonna say self.isRetracted equals false, actually true. So whenever retracted is true, it means that we're not able to write. That little part, I don't know what this little part is called, but that little part is like this. Whenever it's false, it's like this. So down here we can do self.isRetracted equals not self.isRetracted. Let's now talk about this write method. So if we were to say if self.isRetracted, so we can do not, and self.ink level is greater than 0, print. Just like with a function, you can pass in a parameter. Thing to write. And we're going to call this, we're going to type it to be a string. We'll do thing to write. One other thing that I want to include inside of this write method has to leverage this ink level. Every time that we write, we lose a little bit of ink. So we do this by doing self.ink level minus equals 1. So now we know that this condition at some point will fail. Well, and there you have it. Congratulations. You now have a pen written in Python, and it functions the exact same way a regular pen would. It's just expressed a little bit differently. And so hopefully just by this little tutorial here as to how to go about creating those classes, it kind of provides a little bit of insight as to how we can further scale this to be multiple pens. And like I said, a really good exercise for you to do is to see if you can implement a way to be able to say that this is a cap pen instead of a retract pen. So you would take cap off, cap on, rather than retract. So give that a shot, see if that works. Let me know in the comments how you did. And that's all for this video. Thank you so much for watching. If you like this kind of content, again, please subscribe and also like the video. Also be sure to follow us on social media with the links I've included in the description below. Thanks for watching. I'll see you next time.